Hi everyone and welcome to our second part of the integration from 5 to the 3 and maths. Okay, now before that we learn about infinite integral. What is the infinite integral? Okay, you learn in the part 1. So watch for part 1. Okay, and now here if you know what is the infinite integral and what is the relationship between differentiation and this one integration, then here is the second part. Okay, before that we know how to calculate the infinite integral, okay, to calculate the integration. But now here there is a limit here, a new things. You see everything here we have this number. Okay, so what we do, what they use for? Okay, actually there's a limit. That is for a limit from here to here. What is the integration from here to here? And here to here, there's a curve here. We call it as a fx. Okay, so this one equals to what? Okay, when we want to calculate the integration is like this. Okay, do the integration as usual, but now here we make this one become AB, because it's a certain limit. Infinite means infinity, it didn't end. The curve can be go anywhere until the end. Also can, but here cannot. It's a limit, as it means the certain limit. There's a certain limit inside. And we do like this, and we need to do the calculation by two parts. This is for the B, this is for the A, and we do like this. For definite integral, given given I think given like A, and then you can answer B, different thing, but what the relationship you can know like this. If this is A to C fx dx, we can say that there's two things. It's actually combined with BA fx CB fx. I separate the A and C, but if the same variable here is B. If let's say given the question is BA, but now here we need to find AB. Or give question given AB fx is a number, but now question asking for find this one. What we do? You will do like this. Because here is AB. You can rotate, but put the negative sign here because you are doing negation. You do it this way. How about here? This one. If the integration, the function outside got one another thing, another number here, actually you can put it out and can do the integration. This is for the rules for the definite integral. We see some example here. Let's say we see one question here. Given this one, given 2 to 5 fx dx equals to 3. Find the value for each of the following. Here you see one question like this. We show like this. The ballet. This time you didn't know how to do it. Originally this is 5 type. This one is 2 5, right? I will negate it, become negative. 5 to fx dx. This one 2 to 5. Fx dx, and the answer is negative 3. And the second question, here is the same thing, but here go 1 over 2. What you do? I will put out first, and then it's the equal things, because here and here is equal, right, to 3. So I just make this one go out and I put 3. here and do the calculation as usual, you get answer. How about this one? Okay, do one by one, one boxes. Separate two out and then do the step as usual and you get answer. And this one, how you do? Just do as usual, you get answer like this lah. But I very encourage you to make this one like this, 2x divided by 1. Okay, more safer lah. Okay, digalakkan untuk buat macam ni tak payah lah. Ni saya takut dia salah. Okay, sometimes the examiner will overlooking, means will see the wrong answer, see the wrong thing. Then actually the answer is correct, but the examiner put the wrong sign, okay, or deduct your marks. So there's a problem here. Okay. Sorry. Okay, now we will move for another thing. Okay, now I will tell you what is the use for the integration. Okay, there is a definite integral. You see here, area under curve. Okay, given a curve and the question asking you to find the area under the curve, either is from here to here. Okay, if I put the infinity right, okay, the curve is very, very long. The curve can be very, very long and never ends. So it's very hard to find the area. So if I say a certain area here, certain value, certain amount here, okay, from here to here, what is the area? Okay, what I will do? Okay, I will do like this. Okay, A to B, because A to P is here, right? And then because here is a y curve, there's a curve y equal to fx. So obviously, because here touches to y, so obviously I can say this is the y. So the x is the same thing. Here, if I want to find this one. How I do? I want to find this one. How I do? As the same step. Okay, same step. Okay, but I rotate this one. This one still the same thing, but I rotate these two things. Okay, and also sometimes area can be negative if this case only. Okay, if the area is put to here, this is a negative. Okay, in these cases, for this one, if is here, the area is here. Okay, this one is negative. Okay, and when you do like this, okay, the integration, when you do the integration, remember to put the modulus. Let's see another example to let you understand about it. Okay, wait, let me show you. Okay, this is the thing. We see this question. Okay, it is for this. Okay, for this one. Okay, question giving you a left side, right hand side. Okay, the left hand side is the negative and right hand side is the positive area. So how I do? I combine it, right? I tambahkan. But now, because here is negative, the left hand side is negative, so I will put modulus. And then I do the integration step as usual, but please remember to put the sign, modulus sign. Okay? And on complete the step, you open the modulus, and you get the answer in positive answer. Okay, this is for the x dy. Okay, how about this one? It's like this one. Okay, still the same job. Okay, for the negative part, please remember to put the modulus. And this one, as usual, what you do, and do the modulus sign here. Always remember to put the sign until you do the last job. and you get the answer like this. Okay, these two things, I don't know if it's correct or not, but that is the concept you need to know. Okay, this is for a curve only, one curve only. But if, okay, we have one curve and one line there, how you do? Okay, question asking you to find a certain area, something here or somewhere. Okay, the question you can like this. Okay, trying to find this area. Okay, I given you this one and this one I want you to find this one. Can Boleh. Macam mana buat? Okay. I will do like this. Okay, this is the big area. So by using the big area minus with the small area. The big area is from here to here. Minus with the small area is here. So I will get the area here. Okay. What is the big area? Minus with what I don't want. And my answer will become what I want. Okay. I want this. I don't want this thing. So I will the big one minus this one, I will get the small one. If let's say like this, how you do? Same job. Okay. Because here, this one, the line is here. Okay. I find the bigger one first. And then I minus what? I minus with the below here. So that I can get the answer here. I get answer here. This is for the area under a curve. Okay. Now, okay, integration not just using for finding a area of a curve. You also can use for volume. Okay, you see concept here. Okay, this is a surface for a cylinder. Okay, I make like this. Nothing. This is the area. Okay, now I show you a question here. This is what question? This is the question 5. You see it's a question 5, right? Okay, now I want to make this. Okay. Actually, I'm doing the below one, the below part. Okay. I want you to find what is the volume for this area, when I rotate the things in a certain degree. Okay, I will see here is 316. What means by 316? If okay, the curve is like this, and my center is here. The center is here, and okay, the question asking you to find the volume of revolution 360 degrees. I rotate 360 degrees. Putar 360 degree darjah. Okay, or I can set this is 2 pi. Okay, so what I do. So see the things. Okay, 360. This is 90, 180, 270. Okay, original go back here. Okay, 360 means I rotate one circle. Okay, this is how it's going on. Okay, question giving you a curve here. I will draw a curve here, and then I say I want to find the area of here. I didn't got answer. Volume of this part, when I rotate it, come 360. Okay, still the things go back, but actually I doing rotation, and if you form a cylinder, you form a shape that is called circular shape. Circular shape, not a cylinder, but it's a circular shape. Okay. So this is how the concept going on. If like this means our volume of this evolution is a to b, okay, pi x squared dy, because when I say, okay, because the curve is here, but when we rotate 360, here also kena the, you also kena the curve. So it is how the equation going on. But if, okay, I put like this, this is called, this is the up one. Okay, I rotate 360. Okay, this is the, okay, the same area, but I say this is curve here. The curve is here. Rotate 360 degree. Okay, 90, 180, 270, 360. Rotate one circle, but actually the curve here, when you rotate like this, along here also have the curve. So why the curve will be square it? Because the curve will go to rotate, but in different area, in different part, like this. Okay, so this is how going on. Okay, a b pi y square dx. Okay, the things rotate 360 degrees or 2 pi. Okay, that is all about the integration. So we end from here. So now, actually, this question we can change like this. Sometimes we're asking for 316. They're asking for 270. What you do? Okay, we see the question here. Okay, now this is the graph. The graph is here, and then here is the curve. Okay, given you the area, the part of curve is here, and then here you have the shaded region, and question asking you to find the volume when it rotate 270. Okay, actually what I touch here is the center. You see the axis here? That's the center. So I say 217. This is the 0 degree, right? I rotate 270. This is 90, 180, 270. It becomes like this. So I rotate about 3 times. Okay, 360 means I rotate for 4 times. Here I rotate for 3 times. Like this, 3 times only. Okay, and now given a curve here and asking to find this thing, okay, for the volume. First, do the area first. Okay, you need to do what? Okay, you need to know what is the point here. Because here is 4. What is the x for this point? I'll call the point here, and later on, okay, you find the area of here, okay, minus with the area of here, and you get this area, and later on you can continue with the integration. So you get the step like this. Okay, because I said it's rotate 3 times only, not 4 times, 3 times only. So I will do the step like this. Okay, T1, K1, and 1. Okay, that is how the things going on. Okay, in our exam, basically you ask them the question and just like this only. Okay, for the integration, okay, for also for demonstration, not so many questions came out, and also for trial okay, each day will came out 1 times only, sometimes 2 times, okay, in 2 papers, sometimes 1 times in 1 paper. Okay, and here we have some notes, okay, sorry, some exercise for you. We have about 8 exercise, and also we will have about, okay, 3 years of trial papers, okay, and each will have 3 questions, okay, 2025, 2024, and 2023. Okay, I choose the question that is I think it will have a chance to come out in our next SPM. Okay, and that's all, and hope this integration can help you to know more about this calculus. And if you want to join my tuition, one-to-one tuition, is very welcome. You can WhatsApp my phone number, and then I will talk about how to do the question in our exam for this chapter, and I will teach you more about anything about the integration. So that's all for today. If I anything I miss out, you can just comment in the comment section, and I hope the notes that I prepare it can be updated in any time, because sometimes I miss out something. But if you have any question, you can ask, and I hope the notes that I prepare we can make more better. Okay, for our next syllabus we can use it again. Okay, and we will do some updates. Okay, hope this video can help you, and you will see in our next chapter, Form 4 chapter 4, that is called permutation and combination. Thank you so much, and see you in the next chapter. Goodbye.